Okay, let's give number 7 a try. First, take a look at this funny figure. Someone is trying to push this cart of 30 kilograms up a hill and is using 250 newtons of force and travels 12 meters, and the end point is 6 meters higher than when they started, and 10% of the work used is to overcome friction. Now you know this, let's look at this rather long question. A force of 250 newtons is used to push a 30 kilogram wagon up a hill, a distance of 12 meters, bringing it to a point 6 meters higher than its starting point. If 10% of the work done is used in overcoming friction, and A, the amount of work done, find A, the amount of work done, B, the increase in the gravitational potential energy of the wagon, and C, the increase in the internal energy of the system, and D, the increase in the kinetic energy of the wagon, and E, the speed of the wagon at the top. Good grief. Okay, let's look at A, the amount of work done. So the work is equal to the force times the change in distance, 250 newtons times 12 meters. 3,000 joules. The increase in the gravitational potential energy is the gravitational energy is equal to mass times gravity times height, which comes to 1760 joules. The increase in the internal energy of the system. As Barron's explains, the internal energy is the energy produced by friction, so it is 10% of 300 joules, or 3,000 joules, or 300 joules. The increase in the kinetic energy of the wagon. The work produced 3 kinds of energy. The work is equal to the internal energy plus the kinetic energy plus the gravitational energy. So, which is 3,000 joules, which is equal to 300 joules plus the kinetic energy plus 1760 joules. So, the kinetic energy is equal to 940 joules. And the speed of the wagon at the top, the kinetic energy is half mass times twice the velocity, or velocity squared. So 940 joules is equal to half 30 kilograms times velocity squared, which equals 7.9 meters per second. Looks pretty tough, but actually the algebra is quite simple. Give it a try. Thanks very much.